Hi, class. Let's start chapter 7, chapter 10, week 10. Okay, in this chapter, we will be talking about quality management and Six Sigma. I think you saw the video by now, and you have some understanding of what Six Sigma all about. So, our learning objective today is going to be explaining the scope of total quality management in a firm, illustrate globally recognized quality benchmark, understand the Six Sigma approach for improving the quality and productivities, and illustrate process variation and explain how it measures it, analyze process quality using statistics. We're not going to talk about that too detailed, and analyze the quality of batches of the items in the statistic. We'll touch on this a little bit. Now, what's a total quality management? Total quality management, managing the entire organization so that is excel on all the dimension of products and services that are important to the customers. So if you're doing a good operation, you're managing well, then one of the main goals is you're reaching to total quality management or TQM. The two fundamental of operation goals is careful design of the product or services. The second thing is assurance that the organization system can consistently produce the design. So if you want to produce, say, certain bread with certain taste or certain level, you carefully design it in a way that the customer likes it. But the other thing is that your bread should be always like that, consistently produced in that way. So these are two issues, two fundamental issues for operational goal. Now, the quality specifications. First of all, we need to set up the quality specification. So the design quality, the inherent value of the product in the marketplace. So you need to, see what's in the marketplace, what kind of a quality there. You need to be having something better quality if you planning to compete in the market. And conformance of quality, the degree to which the product or service design specifications are met. So first, when you design and you put certain quality in it, and then when you, whether it's met the quality that you set up for it or not. And then you have to do a quality at the source where you making the person who does the work responsible for ensuring that the specification are met. Because whether this is supplier or part of the processor, if his quality is not done well, the next stage will take same product and operate on it, as you saw it in the video. So it's going to be a compiled together a non-qualified product, and could be caused by one stage or a few stages of the work. Now, dimension of design quality. First of all, you look at the performance, the primary product or service characteristic. What kind of characteristics that's supposed to be? Then you look at the feature, which is added touches, secondary characteristics. So you look at the main characteristic, which is supposed to deliver, and then added characteristics that you support you with the quality, how reliable and durable. So how over time are they doing the same level of quality, or it goes down and up. um, probability of chance of failing, how long can be sustainable, this product when they're selling it, people are using it, if it breaks very quickly or does not break quickly. Serviceabilities after you're selling this product, how easy they can repair. Some stuff you don't buy them because it's hard to repair them. The statistic, which is sensory characteristics and the perceived quality, the past performance and repetition. When you talk about Mercedes, whether it's a good product, you have one thing in your mind is quality. They have a good quality of producing cars. But and this is always in your mind, and sometimes you pay for that because you believe the Mercedes have a better quality than other cars, for example. Now, cost of the quality. Does it really quality cost, or really prevent some extra costs that help you to put prevention of that cost is replacing the cost of the quality, really? Um, let's say if something keeps breaking 5, 6 times and you have to spend every time $2 on it, 5 times, which is cost you $10. But if you make it better than the first time, it will break only once, so it costs you $2. But if you want to make it better than the first time, it's going to cost you, say, $4. So $4 plus $2 equal with $6. If you don't do that quality, you have to fix it 5 times, each time $2, that's $10. So it's better that you make a good quality at $6 than you keep fixing it, which is cost you $10. That's the way you look at it in general. The appraisal cost, the cost of inspection, in the quality, cost of the quality that you're looking at is the appraisal cost, like a cost of the inspection, testing, and other tasks to ensure that the product or process is acceptable. That's one cost. The second cost, the prevention cost, which is sum of all the cost of preventing defect. That's something that you need to look at it, as we brought the example of fixing it 5 times, or doing it right the first time and not fixing it at all. Internal failure cost, cost for defect incurred with the system, scrap, rework, and repair. So if something in a process in the system breaks, you have to throw it away, it costs you. You have to rework it again. It's also going to cost you time and effort, or repair it. And it's also going to cost you time and effort. And external failure cost for the defect that passed through the system. If it's defected, comes to the customer and find it defected, will be making a bad impression on them, or might not be purchased at the price that you are asking for. So these are all the total cost of the quality. You need to look at all these in order to estimate how much you're willing to put to have a better quality product. Now, we're not going to talk about ISOs a lot, but we're going to touch on the ISOs. ISOs stand for International Organization for Standardization. Um, Service of standards agree open the International Organization for Standardization. There is so many of them, but the most famous one is they started in 1987. And now it's recognized by 160 countries. You would go and see they hang in a certificate ISO 900 or 1400. Now, a prerequisite for a global competition. Most of the governments also would look at the companies who has been already certified as ISOs. Now, ISO 9000 is directs to you document what you do, and then do as you document. So when you write the documentation of what do you do with the details on it, and then are you doing this according to the documentation that you're doing it? And ISO 1400 is a family of standards on environment management, how you are reusing, renovation, not wasting, not hurting the environment. And there is a ISO 2600, which has encouraged the organization to discuss the social responsibility issues and possible action with relevant stakeholders. Once again, these are basically in 900, 9,000, you document what you do, and then you do as you document it. And this is the most famous one. Everybody is utilizing it. There is a three ways or three certification has three different form. One, you can have what do you call a firm audit itself against the ISO 9000. So you just go and dig in yourself and start audit. The second type is a customer audit its suppliers. So you go and audit and see whether they are doing up to the standard. And the third type is a certifying agency, third party comes and audit you of whether you're performing. And there are three types, all of them acceptable in the market. Now, in the ISO 9000 and ISO 1400, the ISO 9000, which is the quality management principle, is it's supposed to be customer focused. There is a leadership, involvement of people, process approach, continual improvement, factual approach for decision making, and mutually beneficial supply relationship. In a further detailed advanced course, you would take each part of it in a different course, probably, or the same, to understand how these things done. In the ISO 1400, the environment management standard is the definition of more than 350 standards for monitoring the quality of air and water and soil. For example, now in China, they said by year 2055 or 35, I believe, they will have emission free, mean less pollution, or a pollution hazardless. They what they call it. So that's what they're targeting. It's also a strategic approach, requirement of an environment management system, and development of profitable environment-friendly product and service. How you produce a friendly product and services. Now, in the you always, when you're operating, you need a benchmark. Now, whether it's an internal benchmarking or external benchmarking, you have to do some benchmarking. You want to compare your activity today by your activity yesterday or last year. That's benchmarking. If you want to compare your activity today with somebody outside, that's called external benchmarking. So external benchmarking for companies is really looking outside the company to examine what excellent performers inside and outside the company industry are doing in the way of quality. So let's assume somebody is making really good bread, very tasty. You need to benchmark that bread and see how far your bread in comparison with that, bread. Benchmarking step, first of all, as we said, you identify the process that need improvement. So once you see somebody who making better than you product, you look at your product and see how I can improve that. Once you identify the process that need improvement, you need in that identify the world leader in the performance on the process. So you probably go and visit that gentleman, contact that management, and see how they're doing it. Make a visit to interview the manager and workers, see how they're performing to have such a good quality of product. Then you need to analyze the data, which is information that you received and information that you have, are there performance gap between your company and the benchmarking company, which is they making better than you, and you need to close then these gaps. Now, one of the options that you work on it, and we talked about it, the Six Sigma qualities. It is a philosophy and set of method companies uses to eliminate defects in their product. Usually in process, usually this is done to mid-sized to large-sized companies, especially in manufacturing. It's it's it seeks to reduce the variation of the process that led to a product defect. So, when you're producing the process, there's certain process when you're doing a production, and you want to make sure these process stays as doesn't go lower than the standard. Once it goes to lower than standard, you might have a defective product. So a Six Sigma is a statistical term to describe the quality goal of no more than 3.5 defected or defects out of every 1 million unit. So you're producing 1 million unit, you should have 3.4 defects. If you're producing 10 million units, you have only 34 defects product. So that's their goal in Six Sigma. Now there is another one we talked, you saw it's called Lean Six Sigmas, which is a combination of total quality control and just in time, the combination with them. But what is the Six Sigma methodology? Six Sigma methodology is measure, analyze, improve, and control, which is the, the abbreviation DMIC. So first, developed by General Electric, it was developed there as a mean of focusing effort on quality using a methodologies approach. Now you notice now that GE, General Electric, have the very qualified, very good quality product. The overall focus of the methodology is to understand and achieve what the customer wants. So once you built and you saw it, you build what you design according to what the customer wants, then you start building your products according, or you're improving your product according to that. So a Six Sigma program seeks to reduce the variation in the process that lead to these defects. Once you build your product, you need to put a process in a certain level of qualities that doesn't go below that, because if it goes below that, there is a more chance to have a defective product. Now, so the process for it is, the methodology is define, which is identify customer and their priorities. Second thing is measure, which is determine how to measure the process and how it's performed. Analyze, determine the most likely causes of defect and identify the key variables. You improve, identify means to remove the cause of defect. And then you controls, which is determine how to maintain the improvement. Once you do the improvement, you need to control it to make sure it doesn't vary, it goes variables. There is another additional means or tools, which is additional Six Sigma's tools, which is failure mode and effect analysis, is a structured approach to identify, estimate, prioritize, and evaluate the best possible failure at each stage in the process. Let me give you an example. You cannot, one failure might be different than the failure, and two things. One is the chance of that failing happening, if it's 10% or 90%, okay? That's one thing. Then the effect of that failing. Maybe it's a low, but when it's happened is disastrous. So you as an operation manager, you need to look at the chance of this failing happening and the effect of this failing happening. And this is where you seek, prioritize the improvement of reproduction. The other tool is design of experiment, which is a statistical methodology to determine the cause and effect relationship between the process variety and output. Probably you can utilize the marketing research course, cause and effect. If this process goes below the standard by 5%, what's the cause of end product? How many defective product will be facing? This is a cause and effect. You can have kind of a numerical integration, a correlation between them. Now, the statistical process control procedures is concerned with the monitoring quality while the product or service is being produced. So it keeps monitoring the quality. You don't leave it until the product should start getting many product defected. No, you keep process of monitoring these qualities, and each stage you put a benchmark for it. So this is how you do it. Statistical process control is one of the way is testing a random sample of output from a process to determine whether the process will produce item within a pre-selected range. For example, if you're producing 10,000 pants, you cannot test all of them. You can pick any 10 of them randomly and test them and see which part, at which stage, each stage of them, you test 10 pieces and check them whether they are according to the standard, because you cannot test the 10,000 ones. And this you can drive the statistical process control of it. It's like when you do a marketing research, you don't do the whole market research, you do a sample of it. I think some of you guys who took the marketing research understand what it's all about. Now, accepting the sample performed on goods that already exist to determine what the percentage of product conformed to a specifications. Executed through the sampling plan, as we said, is the result include whether you accept it, reject, or retest it. In other words, without going with the details of it, is say if I find 5 pants out of the 10,000 pants, if I picked, I have 10,000 pants. If I picked 100 of them, I start testing them, and I find only 5 of them defected. This probably could be the benchmark for me. Anything more than that, I will reject the whole sum, the 10,000, to make sure that there is something is being need to retest it and bring it to a 5 or less. So the acceptance number of donate the maximum number of defective items that can be found in a sample before a lot gets rejected. Because if the first 5, if you are checking your first 100 and you find, or any 100, and you find 4 of them, anything below 5 probably you say is acceptable, so you're passing that. But if you found 7, 8, you say all that goes back and restarted again. So this is probably, we reached to the end of the chapter without going in a detail of how the statistics it works. And good luck. Bye.